All right, section 8 is on system of equations. These should look fairly familiar from Algebra 1, okay? If not, no worries. We're going to take it slow. If you've got a little bit of apprehension, a little bit of confusion, a little bit of anxiety as we go through these, no big deal, okay? We're going to take our time, make sure we understand how to solve these, and be confident in solving these. Okay, so there are two methods that we're specifically going to talk about in this set of notes. The first one is substitution. All right, and substitution is easiest when you have one variable by itself on one side of the equation, of one of the equations, I guess. Okay, so in this first system, we've got x by itself in that first equation. But in the second system, we've got y by itself in that second equation, okay? Anytime you see that, that connection should be made. Hey, I've got a variable by itself. Let's use substitution to solve this system, okay? So the two examples that we're going to do here show just that. In this first one, I've got y by itself in the first equation. That makes substitution nice and easy, okay? So essentially how substitution works, I'm going to take whatever y equals, okay? In this case, it's 3x, and I am going to replace it in that second equation, okay? And what that does for me, instead of negative 2y, I've got negative 2 times 3x plus 9x equals 5. That makes the second equation have only a single variable in it. And you can solve an equation with just one variable, but with two variables, it's a little more difficult. Okay, so negative 2 times 3 is negative 6. So I've got negative 6x plus 9x equals 5. All right. On the left side, I'm going to combine these x terms. Negative 6 plus 9 is 3. And then to get x by itself, I'm going to divide both sides by 3. Okay, so right here, my x value is 5/3. Now, once I've got that x value, I am going to take my x value and go back up to the equation where y is by itself. Okay, because if I know y equals 3 times whatever my x value is, 3 times whatever I got for my x value. All right, here I see that y equals 5. And so our answer in this chapter, we are going to answer as an ordered pair. Whatever the x value is, whatever the y value is. Second equation, instead of 3x minus 2y, we are going to have 3 times what x equals, which is y plus 1 minus 2y equals 6. Okay, on this left side, I'm going to distribute 3y plus 3 minus 2y equals 6. Combine these like terms that have y. 3 minus 2 gives me just 1y. Plus 3 equals 6. Subtract 3 from both sides, and now I have my y value. Y value is 3. Okay? Now, just because I solve for y first doesn't mean we're going to change what we do. We take that y value that we found and go into the equation that says x equals something. Because if we know x equals y plus 1, and we know our y value is 3, 3 plus 1 gives us 4. So our answer is going to look like our x value first and then our y value. Okay, even though we found our y value first, that's not going to change how we answer the question. Okay. Now, the second method is called elimination. Okay. And to use elimination, we need to have opposite coefficients on one of the variables. All right. So in this first example here, I have a positive 2y in the top, but then a negative 2y in the bottom. All right. That's a good candidate for solving using elimination. Same thing over here. I've got a negative 9x and a positive 9x. Okay. So now we're going to look down here and solve using elimination. Okay. Now, not all of the examples are going to be nice and friendly like the two above. Okay. So this is where elimination is where we're going to multiply the two, one or both of the equations by something so that we can get opposite coefficients. Okay. In this first one, you can choose to get the x opposite, give the x opposite coefficients or the y's opposite coefficients. Either one is fine. Okay. I am going to make the y's have opposite coefficients. Okay. So here, I am actually going to multiply this whole top equation by a negative 2. Ooh, that's fun. Multiply by a negative 2. And then I'm going to multiply the bottom equation by 7. Okay. The top equation then is going to be negative 6x. The top equation then is going to be negative 6x minus 14y equals negative 30. My second equation is going to be 35x the second equation will be a positive 35x plus 14y equals negative 28. Okay, and elimination, it's called elimination because what we're doing is we are going to add these two equations together. And by adding those two equations together, one of our variables is eliminated. That's why we need to have, it's the same number, but one is positive, one is negative. Okay. So if we look at a negative 6 plus 35, that gives us 29x. Negative 30 plus a negative 28 is a negative 58. Dividing both sides by 29 tells me x equals negative 2. Okay. Now, what I'm going to do with this x value, I'm going to take this x value and substitute it into either one of these two equations, whichever one you think will be nicer or easier or makes more sense to you. Okay. Personal preference, it does not matter. All right. I like the top one. So we're going to say 3 times that x value that we found, plus we don't know what y is, so plus 7y equals 15. Okay. 3 times negative 2 is negative 6. Still have plus 7y equals 15. I'm going to add 6 to both sides. On the left, I'm left with 7y. 15 plus 6 is 21. Divide both sides by 7, I get my y value to be 3. So my answer will be in the form -2 because that's my x value, 3 because that's my y value. Okay. Example 4 here. Again, we don't have anything that is opposite automatically. So now you get a pick. Am I going to multiply just the top equation to get opposite coefficients, or am I going to multiply the bottom? Am I going to multiply both equations by something? Okay. Personally, I'm just going to go ahead and multiply this top one by -4. This is not the only way that you can do it. It's part of the fun thing about systems of equations is there are multiple ways to solve them. So it's kind of personal preference and picking out what works best for you. Okay. Now my top equation is -4x minus 12y equals -24. My bottom equation has not changed at all. That's the exact same. Okay. So again, when I add these together, one of my variables gets eliminated. I have a positive and a -4x. All right. -12 plus a -2 is a -14. -24 and a -32 is a -56. So divide both sides by that -14 to get y by itself, and y then is 4. Okay. Now again, I'm going to take this y value and it's going to go into either one of these two equations. If you want to say, oh, I'm always going to put it into the top equation, great, do it. If I'm always going to put it into the bottom equation, cool. If you're like, I'm going to see where the wind takes me, and you pick every single time different one, that's fine too. Okay. I'm going to go ahead and put it into the top equation since x is totally by itself. All right, so I've got x plus 3 times my y value equals 6. Okay, 3 times 4 is 12. And I'm going to subtract 12 from both sides to get my x value. And again, when I answer, I'm going to answer with my x value first and my y value second. Okay, I want you to try. There are 2 examples here. Oh, what? That's being weird. 2 examples here. You get to pick substitution or elimination. Okay, it does not matter which. If you want to try one of each to see what you like better, totally fine. But you are going to solve them. And then we will talk about these 2 specifically in class on whatever day we have class.